Okay, what we're looking at tonight is another IG102 RF generator made by Heathkit, licensed to advanced schools for their training course. And this unit is in wonderful shape. In fact, with the work that it's done on it, restoring it, it looks brand new. I mean, it really does. Beautiful shape. Cabinet has been repainted. As you can see, it did a good job on that. The front face, there's barely a mar or scratch of any type on it anywhere. A little tiny fleck of a scratch over here on the side. But side of that, this is in beautiful shape. I've replaced the original button connectors with the newer BNC bayonet type. That way you'll be able to buy the latest connectors on eBay at the cheapest prices. They're easy to get. You won't have to pay the top dollar for the antique connectors, and I think you actually get a better response. You'll have to have fewer connectors in your on your bench because being modern, they'll match more of your instrumentation. So there you have it. So what we're going to do is we've got this IG102 connected right now to an oscilloscope, and we are at the lowest frequency that it can produce, which is something less than 100 kilohertz. And I also have a frequency counter that's going to tell us the frequency. So right now we're running 95.8 kilohertz. And we're going to take a look as we sweep through the ranges at the signal, and we're going to check the frequency versus the dial, and I'm going to attempt to do them together. But what's going to happen is, if at any point I feel that the trace on the scope is distorted, and I suspect that it's possibly due to the frequency counter, I'm going to disconnect the counter, and we're going to take a second look at it. But right now, we are at the lowest frequency, and we're going to sweep forward. Let's go ahead and on the dial, I'm going to dial in about 100 kilohertz. It'll be right there. And what I'm getting on the frequency counter is 99.6, so very close to 100 kilohertz. Let's go ahead and turn this just a little bit so it's a little easier for us to see it. There we go. And we're going to go ahead and take it up to mid-band. Oh, yeah, while we're doing that, let's take a watch. We've got to watch the scope. Take her up to mid-band. Be about 170 kilohertz according to the band. All right, I don't see anything there. We can see the 170 pointed out on the dial, and we are getting 171.4 on the frequency counter, so relatively close. If I dial just a little bit back, we'll see how far back we have to go to get 170. Alright, that's 170. And it looks to me to be less than 1/10 of a kilohertz on the dial, which is pretty spectacular for a mechanical vernier. Let's go ahead and take her up to, oops, once again, we got to watch the oscilloscope. Alright, let's take her up to 320 kilohertz. And there we go, right about there, 320. We're reading about 320 on the dial, if you can see that. And I am reading 329 on the counter. So let's go ahead and back off to 320. See where we wind up. 320, right about there. And what I'm seeing is I'm at about 300 and I don't know, about 312, 313. Alright, let's go ahead and take her up to the next band, and we'll start over again from the low side. This particular band is 310 kilocycles to 1.1 megacycles. We are right now reading 303 kilocycles, and we're going to take her forward. 310 would be about there on the dial, and we are getting about 308. So we're within 2 megacycles on the dial, which if I was to raise it, yeah, right about there. And looking at the dial, it appears that we are running about, maybe 311, 312, somewhere in there, one or two kilocycles off. Let's go ahead and raise her up. Watch the screen here while we raise it. And we'll go up to about mid-band on this, which would be about 550 kilocycles. That looks to me to be 550 right there, right at that point. And I am seeing 552, so we're within 2 kilocycles out of 550. Very close. Let's go ahead and raise the frequency now, taking her up to 1100, about 1.1 megacycles. And that appears to be 1.1 right there, so I am getting about 112, and about 1.12, excuse me, 1.12 megacycles, and we should be at 1.10, so we are very, very close, right on the dial there. If I was to back off even just a hair, right about there, and we are within about a tenth of the dial space to the 110. Alright, so let's go to the next next band, excuse me, the band C we're on. Alright, band C runs from 1 megacycle to 3.2 megacycle. We are right now at 953. We'll go ahead and raise this to the 1 megacycle point on the dial. That would be right there. And what we see is that we are at 991. So continuing to raise. Right there. That's one. Nudge it just a hair more. There's one. And here's one. Here's 1.1. And there is 1, 2, 3, 4, 5. So we are less than 1 megacycle on the vernier away from it. I'm sorry, 1 kilocycle away from it out of 1 megacycle. So let's go ahead and raise this all the way up to mid-band, which would be in this case about 1.7 megacycles. I am getting 1.7 on the dial and the vernier right here, and we are seeing 17 on the frequency counter, 1704. So vernier was very accurate here. Let's go ahead and continue to, we'll turn up our our scope horizontal so we can see the displayed waveform better. And I'm going to go ahead and turn her up now to 3.2. Read 2 would be right about there. There's 3.2 on the dial here. And we are seeing 323, maybe 322, 323. So we are maybe 0.02 megacycles away from making it perfect, which is really percentage-wise is very small. For a vernier, we're doing very well. And we'll go ahead and take her up to the maximum on this scale and get the 3.36. All right, next band. Starting over at the low end. All right, we are at band D, which covers 3.1 to 11 megacycles. We are at the very low end. We are at 3.03. I'll go ahead and raise this to 3.1. Appears to be right about there on the dial. Right here. Waveform looks good, and we are running at 3.078, so 3.08 instead of 3.1. Very close. If I nudge this up a little bit, we'll hit 3.1. Let's see where we set on the dial. There's 3.1. And I am, maybe 2/10 of the way to 3.2. So 3.12 to 3.2, somewhere in there on the vernier anyway. Let's go ahead and take this up to mid-band. We would be running about 5.5 megacycles, which would be right about there. There's the vernier, 5.5 right there. And we are reading 5.507, so we're right on the money there. Okay, and I'm going to go ahead and raise this up to 11 megacycles. Keep an eye on the waveform. Becoming more efficient at 11 megacycles. Alright, we are at 11 megacycles here. The 11 right about there. And we are reading 11.06, so we were 0.06 away from being perfect, which on a mechanical dial is perfect, believe me. We are perfect. Alright, let's go ahead and raise up our horizontal on the scope a little bit so we can get a better look at that trace. We'll kick up the... There we go. And let's go ahead and go to the next band. Alright. And right now we are running at... we should be running 10 megacycles to 32 megacycles. We are right now at 9.46 at the low end of the dial. If I raise it to 10, I'd be right about there. Alright. 10 would be right on the outer edge. Excuse me. And I'm running about 9.86 out of 10. Let's call it 9.9 out of 10, okay? If I nudge this up a little bit, we'll hit the 1. I overshot it just a hair, but close enough. And we are less than 2/10 away to 11, so we were running 10.2 according to the dial here. in getting one. Okay. Let's go ahead and raise this up to mid-band, which would be approximately 17 megacycles. Right, there's 17 according to the dial. We are at 17 here. And according to the frequency counter, we're at 17.01, so we're dead on. Let's go ahead and raise the frequency. Alright, I'm seeing some distortion here. And let's go ahead and disconnect the counter. Well, before we disconnect the counter, let's take this thing up to 32. And that appears to be 32 right on the dial there. And we are getting 32.2 on the frequency counter. Alright, we see that distorted waveform. Let's go ahead and disconnect the frequency counter. There we go. So the counter was loading it. I knew that was something that happens. And the distortion is gone. So let's go ahead and raise ourselves to the last band. We'll take ourselves down. And we are on the last band. Alright. And what I have here is 32 megacycles to 110 megacycles, which we're running about 32 would put us right about there. Okay. I'm going to reconnect the frequency counter so we can take a look at it. Counter definitely is loading it, but we are reading. I'm reading 32 on the IG, and I'm reading 30.09, so 31 on the counter. And let's go ahead and disconnect the counter for a moment, and we'll run this up to mid-band, which would be approximately 60. A lot of efficiency there. Let's pick, there we go, a little bit, we lowered the sensitivity. 32 to 110, 55 would be what I'd shoot for in this dial, 55 megacycles. And 55 is right here. And let's go ahead and see what we get on the counter. And the counter shows 54.7, so 54.7 out of 55, we're very close. Wouldn't take very much to nudge this to 55. That's over 55 right there. So, and looking back at the dial, I can just, I'm a hairline above 55. And then finally continuing on to the maximum of the IG102. Let's go ahead and turn our sensitivity on the scope down a little so we can see the trace better. And continuing on, maximum is at 110. Which I perceive to be right about there, according to the IG102. right about here. And what I am seeing is I'm at 112 instead of 110 now. Turning backwards a little bit to see how far I had to go to get to 110. Yeah. 110. So on this inside scale, that's 110. And we've gone back about 2/10 of a division rearward. So very, very good linearity between the vernier and the actual frequency throughout all of the ranges. You're able to discern the frequency very, very closely within roughly 5%. I'm going to guess something like that. We'd actually have to do a little math, but and we've looked at the waveform as we went through all the frequencies, and it generates a great waveform, not a problem. Now, as far as internal modulation goes, right now we've been external. There has been no modulation. Let's take a look at the waveform, and let's go ahead and reduce our frequency some here so it's just a little easier to see. Okay. That's a modulated waveform, and then unmodulated. So you can see the modulation is working fine. The internal modulator is great. And we have a port for external modulation here. You could feed a signal in and control the external modulation at any frequency you wanted. Theoretically, you could actually create yourself a small transmitter doing this and transmit on whatever dial frequency you had, taking the output out of an antenna wire if you wanted. Not that that's what it's intended for, of course, but interesting little bit of trivia. The attenuator control, let's go ahead and turn ourselves there. So now we got maximum on the scope. If I turn my coarse attenuation down, I see that I stepped dramatically, and then down again. Not a problem. And then if I adjust my continuously adjustable attenuation vernier, which is right here, fine attenuator, then I see the attenuation change on the screen. So everything on the unit is working wonderfully. The unit is a beautiful looking unit. It will come with a manual, a Heathkit manual, and a new set of leads with the BNC connector and gator leads. Those are the most usable type for just about any situation. This is original manual. Shows you the construction notes, how it was built, step-by-step procedure. Works its way through the theory of operation, calibration, gives you schematic diagrams, pictorial diagrams as well. Now, come on. Component installation, let's see. Just looking for the calibration. Okay, calibration. And then finally the parts and schematic diagrams are here, including my favorite, a 11 by 17 schematic diagram. Very easy to read, very easy to follow. It's been included. So, wonderful version of the manual. You'll be able to keep the thing working, hopefully for a long time. So, happy bidding, folks. Thank you for listening, and we'll see you again.